So once again, my name is Tatiana. I'm data scientist in Disqo, Armenia, here in year 1. I will talk about sentence compression for 2 languages, but general, I would like to give you general introduction to the field and challenges and how can it be solved for any language. So that's the outline of my topic. Firstly, I will talk about what is sentence compression and what evaluation challenges await us there, because that's important for this topic. What data do we have for 2 languages, English and Russian? What are state-of-the-art solutions, including my research and research of other people on this topic? And then I present the summary. So firstly, what is sentence compression? It's a text-to-text writing task, which is summarization on sentence level. So the summarization of natural language text on a whole text level is usually considered firstly by removing some of the sentences. And this is the next level when you have a sentence and you want to make a shorter one, but preserving the main information, and obviously it should still be grammatical and so on. And usually now it's solved as deletion-based sentence compression, when we consider removing some words but do not do any other operations like paraphrase or elimination, or reordering or insertion some more words. So you just remove some words, the other will stay. And you can see example of English sentence on the slide. So as you can see, it can be viewed as a binary classification task of sequence. When we classify words on stay, which is one here, or remove labels, in order to obtain a compressed sentence. So it doesn't look that difficult, but because it's just binary classification. But now we'll talk what are actual challenges here. So unfortunately, it's pretty easy to obtain high metrics like binary classification metrics like F-score on compression task, and still have completely wrong compressions. You can see example on the slide. The source sentence, the gold compression, which is the right one, and some imaginable model compressions, which sounds like this is a sentence about air, which is ungrammatical and it is uninformative. So we don't know what is it about, because it lacks indirect object and it's not a proper English sentence. Then we calculate a precision recall and F-score for this compression, and you can see, well, it's okay. So that's actually the biggest challenge in this topic, that automatic evaluation, that is a binary classification, which is relatively simple, but at the same time, automatic evaluation shows us results which are not to be fully trusted. And even bigger problem is that it's not only about evaluation. Imagine we compute some loss for binary classification, let's say negative log likelihood. We will still have like a good loss for this compression, because the logic is the same as for computing metrics, classification metrics. So there either F-score or negative log likelihood loss will be not able to differentiate between missing some not so important word and missing indirect object, which is very bad. So even if we have annotated data, which we don't have for the most of languages, and we train binary classification, and we obtain low loss and high scores, classification scores, it doesn't mean that we solved it. So my talk today will be devoted on how can we approach solution of this binary classification task, focusing not only on what is classical for solving binary classification tasks, like reducing loss and increasing scores, but what can we do more to solve it really better. And there is even a study recent which shows that high F measure can negatively correlate with some compression quality. So if you want, you can train a model which will have very high automatic evaluation, and even you can publish it probably, because when in comparison, like on conference, usually people look on these numbers, and then compression quality will be very low. So how can we evaluate a different way? In sentence compression, common metrics for evaluation are two: readability and informativeness. And this is like traditional metrics, and readability addresses grammatical correctness, and informativeness shows a degree to which original meaning was preserved. And unfortunately, this is human evaluation metrics. And human evaluation is very expensive, first, and second, it's very subjective. So human annotators in one study and human annotators in other study, even they are annotating the same data and for the same language, it doesn't mean that you can directly compare the results. So that's another problem. But at least if you approach this problem or any problem with like similar challenges where you can't fully rely on automatic evaluation and you need human evaluation, I encourage everyone to ask annotators to annotate gold data as well, so that later other researchers can make comparison of gold data annotations between different people and have like an idea, like mine annotators are slightly more strict than otherwise and have this bias a little bit considered. Okay, what's then? Let's talk about the data. So for English, there are three well-known compression datasets. The first is very big, gigaword, but unfortunately, it's available only with Linguistical Data Consortium license. So if you're a student or a member of a startup, you will probably not be able to afford it. It's very expensive. But some people have access to it, but most of us don't, because it's several $1,000s for the access to the Linguistic Data Consortium data. But there are two publicly available datasets which are called Google Small and Google News, and Google Small is smaller, but it contains more clean data, and Google News Large it can contain some HTML inside it and so on, and usually researchers have to pre-process it. And for Russian, there is one compression dataset which I created and made public, and I will talk a little bit more about it in order to give you an idea how you can approach creation of sentence compression data for any language which doesn't have the ready sentence compression data set. For example, Armenian, I think, probably doesn't. So how I created this data set? I used as a source a plagiarism detection dataset, and plagiarism detection task is a common one, so many languages has plagiarism detection data, and also paraphrase data could be also used. So what I have done with it, I selected, often paraphrase is a result of elimination or otherwise enlarging of the source sentence. So if you take a sentence pair which is plagiarism and source, it's often a sentence compression or vice versa. So I took this pair of sentences, made paraphrase resolution so that sentence compression is the only operation which is done there. Then I made word-to-word alignment with Needleman-Wunsch algorithm for sequence alignment, which is originally, I think it's used in biology to align some gene sequences, but in linguistics, in natural language processing, we use it as well. And then I selected only compression with maximum 0.7 compression rate. Here, I need to say that also it sounds a little bit strange, but that's tradition in the field, that higher compression rate means longer compressions. So compression rate is a proportion of words to stay, which is a little bit unintuitive, but that's the way it is in the field. So I selected only compressions where at least 3 out of 10 words were removed. Then I release a train test split with aligned data, so it's already aligned which word stays, which needs to be removed, which can be used by anyone who wants to solve this task for Russian, but you see it's much smaller than English data, unfortunately, but that's what you would have for any languages which is not English in terms of any data, probably natural language. So I also ask annotators to annotate the first 150 sentences of test set in readability and formativeness, and the mean score of readability is 4.68, and for informativeness it's 4.03. And here I need to say that in compression dataset, informativeness should never be 5 out of 5, because compression will lose some information, but so it's natural to have less than 5 even on gold data. So then what are solutions to solve sentence compression? So for English, state-of-the-art solution includes tree cutting approach. Tree is a syntactic tree of a natural sentence. Integer linear programming approach, recurrent neural networks approach, mainly with long short-term memory networks. Obviously, transformers, recent years, graph convolutional networks, and there are even unsupervised approaches using reinforcement learning and hill climbing. For Russian, unfortunately, there is only one main study with recurrent neural networks and transformers. I will not speak about all of these architectures, because firstly, I don't have time, and secondly, you can probably imagine what means that take RNN and do binary sequence classification. That's pretty obvious. Yeah, it's just learn weights, classify, compute loss. So in the later slides, I will focus on ways how can we address this problem which I talked at the beginning, when there automatically computed metrics, including loss used in optimization, cannot distinguish between ungrammatical and ungrammatical compressions. So how can we address this problem? The first thing is using language modeling objective. So loss functions do not distinguish between really bad and not so good mistakes, so they do not address readability. How can we address readability? The way that we have is to employ language modeling to make readability a training objective. If we take a large enough language model, it will be able to distinguish between grammatical and ungrammatical sentences, and language model training is unsupervised, so we have it for many languages. And then that's my study for using language model later to combine two approaches to create a composite loss function. So here is what's happening. We have a loss which consists of 3 parts. First is negative log likelihood, which is classic, and it's usually baseline in the task. Use like long short-term memory network with NLL, that's their baseline. Then we have language modeling loss. What is language modeling loss? We have some large language model for the language. I used Torch OpenAI GPT transformer, but probably any good enough language model can do. And then to make the function differentiable, we multiply the probabilities obtained from language model by probabilities returned by classification part. And then there is a third component, which is length loss, which is a function of probabilities which corresponds to penalizing uncompressed sentences or to highly compressed sentences, because otherwise language modeling loss it doesn't want to compress sentences. It thinks that the best perplexity we can achieve in natural sentences, why to compress them? So we have to add this length loss component. And I will show the table with results later, but in this approach, we are able to improve readability. But what if we don't have annotated data? Imagine that we are solving this task for Armenian or something, and then this part is not available. Can we do something with that without annotated data at all? And it turns out that yes, there are unsupervised approaches which have this idea that instead of direct access to ground truth training data, they create a set of reward functions that may correlate with different aspects of sentence compression quality. Which aspects do we have? We have readability, and then, as we have already seen, fluency with language modeling corresponds to it. Then we have informativeness, and for informativeness, we can compute similarity to source, like how similar is a target sentence to source with any similarity score. And then we want to compress something. That's why this is the third component, which is length of compression ratio. And if we train this, we use pre-trained model to initialize our weights. Like in this study, they achieve good results. I will share it now. So this is a table with many approaches. I spoke only of several of them, so I will guide you through it. Firstly, here you see just LSTM is a baseline in any study, so we have several of them coming from different studies. Then an approach I talked first, which is my study, to add language modeling objective to loss function. That is this LSTM plus language modeling. And you can see that readability of this approach is relatively high. Like, unfortunately, as I said, it's not directly comparable because to other approaches, because that's human evaluation, but whatever. F measure is not that high, but it's not low either. Then for unsupervised approaches, unsupervised approach is this one. Roberto with reinforcement learning without supervised data, you can see that F measure is low, but it's a recent study, and maybe for English that's not the best idea because we do have annotation data, but for other language that could be an approach. So at least they show that that's possible, and we can approach it for languages where we do not have annotation data, even if now it has lower performance than supervised approaches. Then this is interesting. These are two models of the same researchers, and for the second one of them, their aim was to increase F measure as much as they could, and they achieved their best F measure in the field. And you can see that readability and informativeness are very low compared to their other model. So that's what I was talking about at the beginning, that for such type of problems, automatic evaluation can be very misleading, and they made like the aim of showing it in the study that you shouldn't trust it, and human evaluation should always be conducted first. And second, even in your training procedure, you should think of, does your loss function really see the difference between good and bad performance of the model, or you need to add something like language modeling or some syntax information, let's say, which is logical for natural languages, and so on. So for Russian, that's my study. I have just created baselines which are bidirectional STM and fine-tuned Russian BERT and multilingual BERT models. And for multilingual BERT model, I also tried transfer learning. That is, I trained it firstly on English sentence compression data and then fine-tuned on Russian sentence compression data. And you can see results here. They're not so high measures for English, but the data is lower. And yeah, so what we can see is that higher F measure is for baseline approach, long short-term memory, but actually the highest readability and informativeness we can achieve with multilingual BERT with transfer learning. So we see it again, higher F measure doesn't mean best compressions. And especially like for the model which were not given any additional input. We can imagine that multilingual BERT pre-trained on terabytes of data is more aware of what makes a grammatical sentence than just long short-term memory networks. And that's why even with little data, it's able to produce more readable and informativeness compressions, despite the fact it can't achieve this F measure. So then to the summary. Sentence compression by deletion is just binary classification, so that's simple. And if you look in papers, state-of-the-art models, especially for English, show very good results. However, there are problems. Firstly, automatic evaluation and what is worse, optimization cannot be trusted in this task. So while it's binary classification, it's a tricky binary classification which should be solved with some special approaches. And if you solve this problem or other similar problem, because I'm like 100% sure that sentence compression is not the only problem in the field that have such situation, that laws and measures do not correspond to real quality. You should first think of optimization more closely corresponding to the real-world objective. And language modeling for readability is a good example for it, but I think with other objectives, if you formulate them, you can also think of some approximation which could be computed automatically. And one should always take their time to do human evaluation and error analysis and not just report high F measure, because that's not everything. In some tasks it's not much. And probably there are many other tasks like that in natural language processing, and I think in other data science fields as well. So thank you for your attention. If you have any questions, I will be happy to answer.
What is the business idea behind this problem?
The business idea, well, when I worked on it, the business idea was the following, that the company developed an application like a chatbot which was helping using some knowledge base, and the knowledge base contained an information which was very verbose, and users didn't like seeing in chatbot very long sentences. They wanted, like, that's a chatbot, they wanted a quick answer or something, and their business idea was to shorten this answer from the source. However, I'm sure that for sentence compression there are other business applications as well. But generally, like for any summarization task, we have to read a lot, and not all of us like it or have enough time. So summarization makes sense in lots of tasks, and that's just a subtask of general summarization. Yeah.
I just wanted to ask you, first of all, thank you for the presentation. I wanted to ask you, what in the reinforcement learning task, what were the environments, take and actions, what kind of reward did you get for a good sentence compression, and how it formulated the states for the better future rewards?
Okay. I didn't use reinforcement learning myself, so for details you better to refer to the paper. I have all references in my slides, but I can give you the short answer. So the set of rewards functions was, as I described, to address readability, informativeness, and compression rate. Then, depending on how good was like the performance, this was used to to obtain coefficients and direction of moving features in encoder. So they used encoder and then just used reinforcement learning with this rewards function to change features. Okay, yeah.
So as I understand, you take your model, take a long sentence and return a short sentence with main idea.
Yeah.
And what your model do, it takes the main words using classification and just return this word.
Yeah, that's the idea.
And the training data is following. You take sentence and label it with 1 and 0.
Yeah.
Do you try to take sentence and label it? You take short sentence and as a label you can take short sentence. And your model take short sentence and in loss function output is short sentence. So you can directly take short sentence as a training data, and as a label you can take long sentence, and as a label you can take short sentence. Do you try this approach?
You mean like generative approach to generate, not solve it's like binary classification, but solve it's like a generation from long to short sentence. Is that what you mean? No, personally, I didn't try it, but that's an interesting approach. I don't think it will. So my estimation for this is that it will not be better than solving as classification for deletion-based sentence compression, but that's probably a way to go to general sentence compression when we consider not only deletion but also inserting and reordering operation. That's a way to go with generative approaches and obviously large pre-trained language models in the source of it, otherwise it will not work. But thanks you for your idea.
Actually, I have a question. So you told about the unsupervised approach. So do you think it is feasible to continue in this direction? Would it at some point get competitive results with the supervised version?
Yeah, I think yes, because for most of the languages we do not have supervised data, so it's feasible to address this approach. And it can get compatible results. Language models become like they bigger and bigger every years. So unsupervised approaches start performing better and better. So maybe not at the moment, but in a year, it could happen that it will give comparable performance to supervised. And what's more important, we can use it for languages without supervised data.
Thank you very much.
Yeah, thank you.